Hi there, welcome to my channel. In this video, I'm going to discuss about the solution for word pattern problem. Let's look at the problem description. We are given a pattern and a string s. We have to return if s follows the same pattern. Here follow means a full match such that there is a bijection between a letter in a pattern and a non-empty word in string s. And each letter in a pattern maps to exactly one unique word in the string s, and each unique word in s maps to exactly one letter in a pattern. So there is no duplicate mapping. Let's take a look at the example 1. Here the pattern is A, B, B, A. And the input string is dog, cat, cat, dog. So if we map A to dog and B to cat, we can see the same pattern. So first A, so the dog, and B, B, cat, cat, A, dog. So the string s follows the pattern. So we have to return true. So in the case of example 2, the pattern is A, B, B, A, but the input string is dog, cat, cat, fish. So the dog is mapped to A and the cat is mapped to B. And when we come here to this letter A, we're supposed to have dog, but here we have a fish. So this is not following this pattern. So we have to return false. So the pattern string length is ranging from 1 to 300, and it contains only the English letters, lowercase English letters. And the input string length is ranging from 1 to 3000. And the input string, in addition to the lowercase English letter, it contains spaces. And also S does not contain any leading or trailing spaces. All the words in S are separated by a single space. Let's look at the approach to solve this problem. So the pattern is A, B, B, A. The input string is dog, cat, cat, dog. The expected output is true. We can solve this problem by traversing this pattern in a single pass, and we need some hash map to verify whether the input string follows the pattern. Okay. First thing what we have to do is we have to split this input string into an array of words. Okay. And then as we traverse the pattern, we start building this pattern map and the word map. So this pattern map data structure contains, for each character in the pattern, the corresponding the word that is mapped to it. Okay. So in this case A is mapped to dog and B is mapped to cat. So that's why we are seeing here. And the purpose of this word map is to verify whether a given word is already mapped to a character or not. Basically we need to have a reverse mapping to verify that. Okay. In each iteration we read the character pointed by the IDX pointer, and then we check whether that character has an entry in the pattern map. If there is an entry, then we read the corresponding word and then check whether the words array contains that word in the same index. If it matches, then the input string is following the pattern. If there is no match, then we have to return false. Okay. Basically that character's position and the mapped words position should be same. In that case we are following the pattern. Otherwise we return false immediately. Okay. This is for the case where there is an entry present in the pattern map for the current character. If there is no entry, then we have to create one. Before creating that, we have to check whether the corresponding word has an is mapped to already with some other character. In that case also we have to return false. For example, sometimes we probably have dog, 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 dog. All the four words are same and the pattern is A, B, B, A. In that case, first iteration A is mapped to dog, but in the second iteration we have B and then dog. But that is not valid. So we have to return false in that case. Otherwise, we create an entry, new entry for the current character in both the pattern map and the word map data structures. So basically split the input string into words, and we have to initialize the pattern map and the word map. So the pattern map purpose is to map the character in the pattern string and with the corresponding word in the words array. And the purpose of word map is to find whether that word is already mapped to another character or not. Then we traverse the characters in the pattern string. On each iteration, if the current character has an entry in the pattern map, we check whether the word associated with that current character doesn't match with the word at index idx in this array. In that case, we have to return false. So if there is no entry in the pattern map for the current character, then we have to read the word in the words array at idx position and check whether there is a mapping already present for that word in the word map. If so, we have to return false. Otherwise, we create an entry in both pattern map and word map data structure. So at the end of the traversal of this pattern string, we can determine whether the input string is following the pattern or not. Let's look at the flowchart. Input for this procedure is a string S and then a pattern. First we initialize the pattern map and the word map hash maps data structures, then initialize the retval variable, and we create an array of words from the input string. Basically we split this input string with space as a delimiter that will produce an array of words. Then we check whether the length of the pattern is equal to the length of the words array. If they are not matching, then the input string is not following the pattern, because it should match for each character in the pattern should match a word in the input string. So if the length is not equal, then we have to return false. Otherwise, we enter the for loop which traverses the characters in the pattern. So for each iteration, we read the character in the pattern string and check whether there is entry in the pattern map data structure. If there is then we have to verify whether the word present in the corresponding IDX is equal to the value present in that map entry. If it matches, that means the input string is following the pattern. Otherwise, it is not following the pattern. So for not matching case, we have to return false and come out of the function. If there is no entry present in the pattern map data structure, then first we have to check is whether the current word is already mapped to a different character. So for that we have to check whether the word is present, an entry for that word is present in the word map data structure. If there is an entry, that means the current word is already mapped to a different character. So in that case, the input string is not following the pattern. We have to return false. Otherwise, we have to create a new entry in both pattern map and the word map structure, and then we move on to the next character in the pattern string. So once all the characters are processed in the pattern, then we return the 12. Let's move on to coding. First, I split the input string into an array of words. Then I initialize the pattern map data structure, which is a map of run to the string, and then a word map data structure, which is a map of string to run. Then I check the length of the pattern and the length of the words array. If they are not matching, then I return false. Then I traverse the characters in the pattern string. By default, this function returns true, and first I check whether an entry present in the pattern map data structure for the character ch. If there is an entry exists, then I compare that word, the corresponding word, with the word at index idx in the words array. If they are not matching, then the input string is not following the pattern, so I return false. So if there is no entry for the current character ch in the pattern map, then I read the word at index idx and check whether that word is already mapped to some other character by checking the word map data structure. If there is an entry exist for that current word, that means the input string is not following the pattern, so I return false. The current word is mapped to a different character in the pattern already, so that's why it's not following the pattern. And if there is no entry for the current word, then I create a new entry in both the pattern map data structure as well as the word map data structure. Next, I'm going to run the test cases. All the tests passed. Next I'm going to submit this program. Cool, this program is accepted. Next I'm going to do the code walkthrough with sample input. Let's do code walkthrough for this input. So the pattern is ABBA and the input string is dog, cat, cat, dog. The expected output is true. Okay. First we split the input string into an array of words. So we have dog, cat, cat, dog. This is an array. And then we initialize the pattern map and the word map data structure. So both are empty. Then we check whether the length of the words array and the length of the pattern is equal. If they are not equal, then we have to return false. So in this case, both are 4, so which are equal. So in this case, the length of the pattern is 4 and the length of the words array is 4. They are equal. So we are proceeding to traverse the characters in the pattern string. Okay. So in the iteration 0, so the index is 0 and the ch will have the value of the first character in the pattern A. Okay. Here we check whether there is an entry in the pattern map. There is no entry. So we go to the else part and we read the word present in the index 0, which is dog. We check whether there is an entry in the word map for the word dog. So in this case it is not present. So we go ahead and create an entry in both the pattern map and the word map data structures. So we have one entry in each map. Okay. Then in the next iteration 1, the index IDX is 1 and CH will have the value B. Again we check whether there is an entry in the pattern map data structure. There is no entry for B. So we come to the else part and we read the word, which is a cat, and there is no entry in the word map for the word cat. So we create an entry in both pattern map and the word map for the word cat and the character B. So in the iteration 2, the IDX is 2 and the character is the CH will have the value B. We check whether there is an entry in the pattern map for the value B. There is an entry. So we read the word and compare that with the value present at IDX in the words array. In this case IDX is 2. So the IDX, the words arrays index 2 have the word cat, which is matching. So we are proceeding. If it is not matching, then we have to return false. In this case it is matching, so we are proceeding to the next iteration. So now the IDX is 3. So we are reading the character A and assign it to CH. And we check whether an entry for the letter A in the pattern map, there is an entry. We check whether the word present at index 3 is matching with the word dog. So in this case it is matching. So we are proceeding to read the next character, but we reach the end of the pattern. So we break out of the loop and finally we return true. That is an expected output. Next I'm going to do the time and space complexity analysis for this solution. Let's do the time complexity analysis for this input. The pattern is ABBA. The input string is dog, cat, cat, dog. In order to determine whether the input string is following the pattern, how many iterations this for loop performs? So it has to, at most it has to perform 4 iteration. Because the pattern string length is 4, we have to do 4 times. If the length is n, then we have to do n times. So the time complexity is order of n. And the space complexity is also order of n, because we need to build the pattern map and the word map data structures. Their size is depending on the input size. If all the characters in the pattern is unique and all the words in this input string is unique, in that case we have the size of these two data structures will be equal to the size of the input. For example, in this case we have only two unique elements. Though the length is 4, we have only 2 unique elements. So we need only 2 entries in the hash maps. For example, if it is a dog A, B, C, D, dog, cat, elephant, lion, in that case we need 4 entries in the hash maps. For n number of characters in the pattern, we need hash map with n entries. So the space complexity is order of n. Thanks for watching this video. Have a great day.